In this video, we're going to learn how to use Excel's solver function in order to help us solve a linear program. So Excel Solver is not one of the applications that is installed with the basic installation process for Excel, so it is something that we will have to make sure that we enable as an add-in. To see if you have it or not is really straightforward. If you click on your Data tab, we had already used data analysis earlier. I've already enabled the solver function. If you do not see solver appearing under the data tab, under analysis, you'll simply need to go to File, Options, Add-ins. At the bottom, Manage Excel Add-ins, hit Go, and simply ensure that you have clicked the solver add-in. Once you hit OK, you should see solver right away. If it doesn't appear automatically, simply close and restart Excel and it should be there. Okay, with that, before we actually use the solver application, there is some setup that we need to do in order for Excel to actually be able to do its work. Whether we're doing this by hand with the use of graphs or doing this in Excel, we sort of start in the same spot. We first have to create our linear programming model. If you remember, when we completed this question by hand, we came up with the following linear programming model. And now we simply need to recreate that in Excel. So the first thing we're going to do is to simply have somewhere in Excel where we're going to input all the given information. Any calculations that are going to be made, we want referencing back to this given information part, so that if we do end up changing something or a correction needs to be made, there's only one spot where we will actually enter data. We don't need to go and hunt through a whole bunch of different cells and figure out where did I put stuff in, where did I not. So I'm going to simply start somewhere in the top and enter something that recreates this sort of information in Excel. Label it in any way you desire, whether it has something to do with the question. For now, I'm just going to refer to this as given. And we have some information that is given to us in terms of wheat, some information that is given to us in terms of barley. Again, I never like to enter just numbers in a cell. I always want to reference what those numbers are referring to. So if I'm going to do something that's going to sort of recreate my objective function, I don't want to just reference numbers of 5,000 and 3,000. I'll make a note to myself that the numbers that are going to appear immediately to the right of this will refer to something to do with maximizing the profit. So max profit will come from every acre of wheat will give us $5,000 profit. Every acre of barley will give us $3,000 profit. Similarly, I'll get all the information in terms of the constraints. So we have an acreage constraint. So in these cells now, I want to reference what the coefficients associated with the acreage constraint are. Doing this by hand, we have an understanding that in front of the variable W in my acreage constraint, there's an unwritten 1. Excel doesn't have that same understanding. So I'm simply just going to enter that the coefficient associated with that W is 1, with the B is 1. And now we have also a right side of this constraint representing the total that we have available, or in this case a total of 8 acres available. So similarly, I'm going to recreate the pesticide constraint and say that 2W plus 1B has something to do with the right side, or a total of 10. When we do this in Excel, this final constraint, our non-negativity constraint, you'll see we don't actually need to enter that constraint in terms of given information. Once we bring up solver, you'll see there is a spot where we can highlight that we want to ensure that the variables are always non-negative. So in terms of given information, really we have all we need for this question. We've got our objective function represented, we've got our two constraints represented, and now we can go and create the Excel functions that solver is going to use in order to solve this linear program. So we have our given information. Now it's about having Excel do some work. So our actual model, again, we want Excel looking for W and B. Now below these two cells, I'm not going to enter any functions or anything. This is where Excel is going to spit out what the optimal values of W and B are. And again, this step is totally unnecessary. Personally, I like to highlight this so I know that when I get a value into the cell later, this is an important thing. This is something to do with Excel telling me what the optimal solution is. So I just like to make it stand out in some way. Not only do we want Excel telling us what the optimal values of W and B are, we also want it to tell us, based on those values of W and B that it's going to spit out, what the maximum profit that we can achieve is. So in this cell for max profit, again, this will be something where I have Excel giving me important information, so I'm going to make it stand out by highlighting it in some way. I now need to recreate a function that Excel will use in order to calculate what the maximum profit is. So really what we're trying to do is to recreate this part of our linear programming model. And again, remember, all of our calculations, we want cell reference. We don't want to input any new information in this. So in order to calculate the max profit, I want Excel checking my profit for wheat times however many acres of wheat Excel tells me that we should plant, plus $3,000 in profit for every acre of barley, so 3,000, or a cell reference to 3,000, times the cell reference to where Excel is going to tell me how many acres of barley we should plant. And now once we have values for W and B in there, Excel should be able to determine what the maximum profit amount is. So we've set up a function for our objective function. We now need to set up functions for our constraints. So we're going to have the same two constraints, acreage and pesticide. So we're first going to create an Excel function that will represent the left side of the constraint. So again, cell references to anything. And as we said, even though we understand there's an unwritten one in front of there, and I really could just reference the cell where Excel is going to spit out how many acres of wheat we want to use. If we cell reference this value of 1, just in case we change that later or we realize we've made a mistake, I can simply change this cell and Excel will be able to update my entire linear program later. I want to reference the cell where I have the coefficient dealing with W for my acreage constraint times how much wheat we're going to use, or how much wheat Excel is going to tell me how to use, plus the coefficient for barley times how much barley Excel tells me we should plant. And again, if we do this in this manner, where we have a coefficient for each variable, each of those coefficients will always be referencing back to what Excel tells me the optimal amount is. So in creating the formula for the next constraint, I'm simply going to use my coefficient of W, coefficient of B, times always the same value here. If I create absolute cell references for the ones that refer back to the optimal solution, what we should be able to do is to simply copy and paste that formula down. So as I copy and paste down, I see that for the first constraint I created, it's referencing my two coefficients for that constraint times my optimal solution. And then because of the absolute references, when I go to check the pesticide constraint, again, now it's moved the non-absolute reference cells down 1. So now I have the coefficients of the pesticide constraint. But again, because of the absolute reference here, times the optimal values of W and B. So with that, we have the left side of each constraint completed. I'm just going to make a note to myself, and this is totally unnecessary. Excel won't be using this at all. But as I said, this is just a note to myself that both of these are less than or equal to constraints. And now recreating the right side of each function, again, I don't want to input any new information here. I want to cell reference back to the given information section that I created to start the question. So the maximum allowable acreage is 8, and the maximum allowable pesticide usage is 10 gallons. With that created, we now have everything we need in order to have Excel complete this model. So once we have our max profit function completed, all our constraints completed, we can now go into Excel Solver. And in Excel Solver, we're going to input the model that we just created. So the first thing we want to make sure we do is we reference the appropriate objective function cell. So that's where we had our max profit formula created. Next, we want to reference whether it's a maximum problem or a minimum problem that we're trying to solve. By changing the variable cells, where the variable, the things that we're trying to solve for, are W and B. With our variable cells input, we now add our constraints. And as we add constraints, we see that basically this new window is referencing the left side of the constraint, the right side of the constraint, and the operator in the middle. So one nice thing in Excel is if all our constraints are all less than or equal to, or all greater than or equal to, or we have a bunch in a row, we don't need to add each one individually. I can highlight multiple constraints at the same time that have the same operator. So since these are both less than or equal to constraints, I can highlight both constraints at the same time. Make sure that I have that it's less than or equal to. Now, the right side of the constraint, making sure that the right side reference to the same constraints that the left side did on as we input those first values. Hit OK. Now this next box, this is defaulted to be ticked, and this is why we didn't have to enter those non-negativity constraints. So just ticking, make unconstrained variables non-negative. Always ensure that that is clicked. Last but not least, remember everything we do will be a linear program. It is defaulted to non-linear. We want to choose a simplex linear program, simplex LP. With that, we should be able to hit solve, keep solver solution, hit OK, and we can see that Excel has spit out that we should plant 2 acres of wheat, 6 acres of barley with a maximum profit of $28,000. And that should be the exact same answer that we found as we did this by hand.